Hello friends, welcome back to my YouTube channel MS Maths. In this particular video, we'll discuss about the source and sink. So basically, in the previous videos, we have discussed about what is the fluid dynamics and basically various topics of the fluid dynamics we have already covered. In this video, we'll start the source and sink. So what is the source and what is the sink? In general, a source is something which is which is producing, okay, and sink in something which is gaining or in which all the things will observe. Okay, so the same concept is here. Whenever you will have a function or sorry, you will have a fluid which is a potential kind of function. So then we'll talk about the source sink. It means basically we have discussed the potential function in the previous videos. So let's start the sink and let's start with the definition of the source and sink. We'll continue with the example and the doublet also. So if the motion of the fluid consists symmetrically radial flow, it means if the motion of fluid is consists symmetrically radial flow, if it means the motion of fluid in such a way that it is a radial flow, okay, or basically in such a way, this is the in such a way that it is a radial, it means there is a radial velocity and transversal velocity, two types of velocities there. So the radial velocity is basically in which the radial velocity is here. Okay, so if the motion of the fluid consists symmetrical radial flow, so the flow is symmetrical radial in all direction, producing from a point. If it is producing from a point, then it is called the simple source. Okay, then this is called the simple source. Okay, the radial symmetrical flow of the fluid which is producing from a point only, that particular point is called the simple source. If the flow is such that fluid is directional in radially inward, okay, so the flow is in such that fluid is directional in such that the point from all the directions symmetrical manner, it is called the simple sink. Means producing from a point is called the sink, and point in which the flow is going inward or radially inward, that is basically the sink. Okay, in 2D flow, a source of m is basically the strength. Okay, m, like here we are going to like denoting the strength of the sink and source by m. Okay, and the strength of the source is minus m, and it is depending on the like direction. Okay, so this is the all the game of the direction, so we'll discuss later on it. So first of all, we will have and strength m in such that the flow across any small like surrounding of 2 pi m, and sink is regarded as source of the strength minus m. Okay, so here we have the sink and source with respect to the strength is basically the minus m and sorry, m and minus m, and there is a circle. Obviously, if it is a radial flow, symmetrical radial flow, then there is a circle of the radius r with the source and its center. Okay, source at its center, and gradient velocity, that is basically the qr is the whole velocity. It means it contains the transverse at as well as the radial velocity is also here with a, yeah, qr is radial velocity because it is a radial symmetrical flow. No? It is a radial symmetrical flow, then it is called the radial velocity, and one thing is a transversal velocity. Okay, so basically what is happening here, basically the radial velocity is nothing but that we have radial velocity is what, qr is something denoted by minus 1 by r dou psi by dou theta. Okay, so this is what from the CR equation of the complex potential function, that is basically I guess it is psi plus, okay, phi plus iota psi. Okay, this is my potential function and this is my uh, potential function and streamline function. There were two type of function. That potential kind of function is by phi plus iota psi. Yeah, it is potential function is my phi, and the another function is psi is basically the stream function. Okay, the stream function and potential function, in which the relation is basically 1 by r the partial derivative of the psi with respect to the angle theta is nothing but dou psi by dou r, which is the direction or the radius, you can say. So I can just simply write here QR is equals to minus dou phi by dou r. So 1 by r dou psi by dou theta is nothing but this is by the CR equation. Okay, this is by the CR equation, Cauchy-Riemann equation in the complex analysis. Along a circular symmetrical, along a circle, because it is a symmetrical, it is a symmetrical radial flow. So if it is a symmetrical radial flow, then obviously there will be a circle of radius r, and we have the source at the center of the circle. Okay, then the relation is basically the 2 pi r into velocity. Yeah, that is the basically the length. 2 pi r is the length of the circle. It means it is a perimeter, and the velocity is basically the qr, which is nothing but equals to the mass 2 pi m. Okay. Now, what will happen here that Q of R, this is the relation from the formula and this is the relation from the physical problem. It means like what is happening here. Okay, so it is QR is basically M by R. Then I can write it as, yeah, what is the, like I said this is my equation number 1. So from equation 1, then I can write here minus dou phi by dou r is equals to m by r. So what can I do here? I can write 1 by r is equal 1 by r of dr, or basically dou r, you can say 1 by r dou r minus of dou phi by m. I'm just separating the variable in this differential equation. Okay, so what is going to be here? The next term is basically the integration, that is nothing but integration log r, and it is what? Minus of phi by m. Okay, then it is log of r is equals to, or I can write my phi is nothing but minus of m into log of r. So yeah, we can write here c because we are different integrating here. So this is the phi function and it is nothing but potential function. So the potential function is here for this particular case is basically minus m, that is the strength of the source or sink. If the strength of the source is plus m, then strength of the sink is obvious minus m. Okay, invertly radially. Okay. Now let us assume that for potential kind of function, because we have a potential kind of function is basically, sorry, complex potential function is phi, sorry, like w, or we can say omega, that is nothing but phi plus iota psi. So we have to assume, let us take psi is equals to my minus m theta. So what can I do here? So I can just write uh, what is my potential kind of sorry, complex potential function is phi plus iota psi here. So I can write w is equals to minus m log of r plus c and minus of m theta. I have taken here c as 0 because this is the function. I have just neglect the integral coefficient, or we can say that constant, arbitrary constant. So it is just minus of m. We can take common here. So it is log of r plus theta. Now I can write this theta as minus m. Of course, there is iota is here also. So theta iota, I can write this is my log of r plus log of e to the power iota theta base e, obviously. Okay, so this can be written as minus of m. Thus, the multiplication is going to be r e to the power iota theta. Okay, so this is basically the complex function. Then w is equals to minus m. This is your log of z. The polar form of the z is nothing but r e to the power iota theta. So it is my minus m log z. So this is the potential kind of function. So that W is equal, this is basically the source. This is basically the source or equation of source at origin. The equation of source at origin. If it is W is equals to minus log of Z minus A, then it is the source at a comma 0 because it is on horizontal field. So it is 0, then it is a comma 0 and it is 0 comma a. If it is z minus a, then it is here only. This is at where the equation of source I'm denoting by the red color. It is minus m log of z minus a. Okay, if it is here only, then it will be, yeah, it is minus of, sorry for that, it is minus of a comma 0, minus of a comma 0, then the equation is here minus of m log of z plus a. These are the equation of the source, and minus here is minus of log z. So by the red color we are just denoting the equation of source, or the, sorry, by the red color it is the source, and green color we can, it is sink. So what is the equation of sink here? Just opposite strength. So here is m log z plus a, here is m log z, and here is plus m log of z minus a. So these are these like positions of the sink and source. By the equation we can find, or by the potential, by the complex function we can find it. Now come to the next topic, doublet. So what is the doublet? Doublet is nothing but the combination of the sink and source. Okay, doublet. The combination of source and sink of strength m and minus m respectively at a small distance, say delta s apart, wherein the limit m is taken infinitely large. It means that if we take the strength is infinitely large, so the distance is going to be 0. Okay, so the distance as infinite, so this distance will going to be small. So m into delta s is a finite quantity, where m delta s is nothing but mu, where mu is called the strength of the doublet. Okay, now if it is a strength of the doublet, so we have the keynotes what? Whenever the m or the strength is taken infinite, it means if the strength is infinite, then the delta s should go to 0. It means that the m into delta s denoted by the mu is, it is basically the strength of doublet, denoting the doublet by t. So the complex potential due to doublet. What is the complex? This basically, this is the complex potential. This is the complex potential function. What is this? This is the complex potential due to source. And this is what, by the green color, it is by sink. Okay. So here we are going to find the complex potential due to mu. It means complex potential due to a doublet. So how can we find by the doublet what is the complex potential? So we'll just write, if we have m and minus like m and minus m are basically the strength of the sink and source. So I can yeah, I can make a diagram here so that it will be more clarified. So yeah, if it is a triangular, it is in a triangular way such that, okay, I can make triangle with this, sorry. Okay, I can't make like this. Wait. Yes. If I have this is a triangle, say A, B, C, O here. So it is, yeah, A, B, and P is here. So I say just this is my some source. This is say source, and this is sink of strength M. Then this is the distance delta S. I say this is my R1 distance. Here is, we can write this is also delta S. Here is also M, we can say. And this is my R2 distance from the P, that is the resultant. Now, A and B denote what we will write here. So we'll just write some theory explanation of the diagram. A and B denote the position of sink and source, and P be any point in the fluid. This is all the things will happen in the fluid. Okay, fluid medium. P is a point in the fluid medium. So I say my AP is equals to R1, BP is equals to R2, and the angle PAB is equals to theta. It means this angle is theta here. Okay, you can see the diagram. So this angle be the theta. Now, let phi be velocity potential function here. Let phi be velocity potential function, then velocity potential function due to doublet phi is equals to m log r1 minus m log r2. Okay, so the strength, okay, that is m log r1 minus m log r2 is the value of the phi. So I can write it as just m into log of r1 upon r2. So the phi is equals to minus m log of r2 upon r1. Why we are doing this? Okay, just we got the next step. If my r2 is equals to some r1 plus delta, then what will happen? Phi is equals to minus m log of 1 plus r1 plus delta r divided by r1. So the phi is equals to minus m log of, it is 1 plus, oh sorry, 1 plus, now it is 1 plus delta r upon r. Okay, so this thing will be r, delta r is small. If we divide if we divide r1 in the delta, then it will be very small. So it is what, very small distance here. I can write phi is equals to minus m delta r upon r. Now, this is basically the first order approximation here. Okay, this is the Taylor series. What is this? This is what, like something x plus h here. This is first approximation we can write. So this is just the first approximation here. First, this is by the Taylor series. Okay, first order approximation. Now phi is equals to what we can write here. If it is I is equals to minus m delta r. Okay, now we can find just here what is my delta r and r1. So I can drop a perpendicular here. So I can just find what is my cos of theta here. Cos of theta is what? Am divided by delta s. Am divided by delta s. With Am divided by delta. So this is not delta s. Wait. Sorry for that, this is by mistake. It is not delta S here. So AM divided by what is cos theta here? Cos theta is this with the angle. So I can just write what is my delta S here. So I can just write delta S or delta, oh yeah, AM is delta R. AM is delta R. So it is cos of theta is equals to delta R upon delta S. So what is delta R? It is cos of theta into delta S. So I can just simplify, or I can just put here minus of M and the cos of delta S divided by delta R. So this is the complex potential function, or basically what is this? This is what? This is the mu, the strength of the complex potential function. Now, actually, we want to find the complex potential due to the doublet. So what is the complex potential? It is omega plus phi iota sine. Now, we have phi. We'll just assume what? We'll just assume phi. So how can we assume that? If it is, see, so I can write my phi is equals to mu. It is the mu because we have already considered that this is mu. So it is what? Mu cos of theta by r, or just replacing r1 by r. So dou phi by dou r is equals to minus, yeah, it is also minus. So minus mu cos of theta, not, it is not minus here. It should be plus, I think. After approximation, I think after approximation it will be plus, because in the log first term is minus. Yeah, this is plus, this is also plus, but by the differentiating with respect to r, it is 1 by r, that is minus 1 upon r square. Okay, now we'll just find minus 1 upon r square. Okay, now we have what is the value of dou phi by dou phi by dou r cos of theta. I think there is a mistake here. First approximation is going to be 0. Sorry, it's not going to be negative, it is positive, it is also positive. This is my equation number 1. Okay, then this is what? This is the equation number 1. So it is what? R1 and R2 is here. Then dou phi by dou r is what? Minus mu cos of theta by r1. If it is minus, then it should be plus here. Yeah, it should be plus here. So just consider this is my equation number. Sorry, this is my equation number 1 here. Now, the earlierly we have seen that dou phi by dou r is equals to 1 upon r dou psi by dou theta, because we want to find the psi here. So we'll just put the value from equation number 1. So from equation number 1, mu cos of theta upon r square into r, we'll take this r here, is equals to dou psi by dou theta. So it is minus mu cos of theta upon r is equals to dou psi by dou theta. So we'll just find the value of dou phi here. So we get dou theta. So minus of cos theta and dou theta, then r dou psi. We'll just integrate. So we'll get here psi is nothing but minus mu. Psi is nothing but minus mu by r cos of theta. Sorry, sin theta minus mu, or basically, yeah, cos, the integration of cos is minus sin theta divided by r, and here is some function of r, because we are differentiating with respect to theta here. Yeah, then if we differentiate with respect to r, again this thing, then minus minus will be plus mu sine theta upon r square, and this is f s of r, because this is a function of r. Because we have the partial differentiation with respect to theta, so this is going to be constant for the theta. Okay, so Now, if the if we compare these both thing will here, if we compare these both thing, then f dash of r is equals to 0. If we compare this from the derivative or the basically phi theta dou phi by dou r, then f of r is equals to constant here. So that we have now phi function and sine function both, sorry, sine and phi both, then we can find the complex potential due to the doublet. It is basically phi plus iota sine. So whatever these values are, basically mu cos of theta upon r plus iota minus mu sine of theta upon sine of theta upon. So basically, if we will find the value here, so that is basically mu by r and cos of theta plus or basically minus of iota sine theta, and it is going to be by Euler's theorem. So 1 by r e to the power minus iota theta. So we can just write w is nothing but mu upon r e to the power iota theta. So we can just write it is a complex function or complex variable mu by z. So here this is the complex potential due to doublet. So this is all about the complex potential function and the doublet here. So this is the sink and this is the concept of the sink, shows complex potential function and doublets. Thanks for watching my video. Keep watching Ahmed's Maths. For more videos, please subscribe the channel, share the video. Thank you. Bye bye.